molecular structure and properties. So here are the two compounds that I'll be representing for this assignment. Number one is trichlorofluoromethane, which is comprised of 3 chlorine atoms, 1 carbon atom, and 1 fluorine atom. As you can see, the carbon is the largest because it is naturally larger than chlorine and fluorine, followed by chlorine, and then fluorine is as the smallest. As if you look at a periodic table, you'll understand why, as elements on the right side are just smaller. I chose cherry tomatoes for chlorine, for a very specific reason, which you'll see later. But just so you know now, I do not like cherry tomatoes. We are not attracted to each other at all, and this is a very bad chemistry joke. This is a tetrahedral for its shape, mind you. The next compound is ozone, which is trioxide. Much simpler, and it is much more unstable due to having a double bond, which can be seen as this way or this way. It is a bent shape due to the 2 extra electrons up here pushing the 2 other oxygen atoms down. And this is very, very reactive compared to this, which is much more stable. Starting with electronegativity, this compound has all polar bonds, as carbon has the smallest electronegativity of the bunch, meaning that all the electrons are drawn towards the 3 chlorine and the fluorine element on top. This also gives it its shape, and it's actually a polar molecule because the chlorine atoms have a smaller electronegativity than fluorine. Thus, the polarity goes towards the fluorine, which means most electrons are drawn towards there. This would be the positive side, I suppose, and this would be the negative side. This is a dipole-dipole compound, meaning it's the most stable and they hold pretty tight together. Obviously not as tight as an ionic compound. I kind of made a mistake in constructing these because this one is actually a lot more stably constructed compared to this one, which is actually false because this is a much more stable compound. However, I guess I'll make it work. Anyway, moving on to trioxide, we might think this is much easier, but it's really not because there are some complications to it. First, this obviously has nonpolar bonds. Since all the elements are the same, the electronegativity difference would be 0. However, this is a polar molecule due to the bent shape and the 2 extra electrons up here, thus making it polar by having 1 charge up here and 1 charge down here. Actually, this side's the positive because there are less electrons near the top, while there are more electrons near the bottom. So it experiences dipole-dipole forces, although it is very close to just being a nonpolar molecule and only experiencing London dispersion forces. This makes it very unstable and very reactive, which I'll get into later. Yet another byproduct of me constructing these with fruit, I couldn't control color, so they don't really represent their color very well. Anyway, speaking of physical properties, this is a liquid at room temperature and it is made to be a refrigerant, which is trichlorofluorocarbon, keeping things cool. It is colorless and odorless compared to ozone, which is found in the ozone layer, obviously, which is actually a bluish gas and is quite pungent. This has a very high boiling and melting point since it has very strong dipole-dipole intermolecular forces, compared to ozone, which does have dipole-dipole intermolecular forces, but has very low boiling and melting point since it is quite weak. Now, these two wouldn't react naturally since they don't really meet, nor is trichlorofluorocarbon reactive. Well, this isn't, since it's kind of satisfied. If they did, it would react something like this, the positive side of the ozone coming to the negative side here, and sharing electrons in that way. However, where they do react is up in the ozone layer. Since this is so unreactive, its lifespan is very long and allows it to make itself to the ozone layer. And in the ozone layer, there's this little thing called UV rays that hit the trichlorofluorocarbon like a beam, breaking it into pieces, bringing chlorine atoms, carbon atoms, fluorine atoms apart. And the reason I chose cherry tomatoes for chlorine is the specific reason. Chlorine, when it gets separated and meets with oxygen, produces a little friend called chlorate, which is unstable, so it's also very reactive, producing even more, and is destroying the ozone layer. It's like taking a grapefruit like a grape, which I'm going to take off right now, and then combining it with a fruit like a cherry tomato, which you put in your mouth, and that's what chlorine is doing to the ozone layer. In fact, it has a more potential global warming effect than carbon dioxide.